Types of data and the scales of measurement. Data is a valuable asset, so much so that it's the world's most valuable resource. That makes understanding the different types of data and the role of a data scientist more important than ever. In the business world, more companies are trying to understand big numbers and what they can do with them. Expertise in data is in high demand. Determining the right data and measurement scales enables companies to organize, identify, analyze and ultimately use data to inform strategies that will allow them to make a genuine impact. Data at the highest level, qualitative and quantitative. What is data? In short, it's a collection of measurements or observations, divided into two different types, qualitative and quantitative. Qualitative data refers to information about qualities, or information that cannot be measured. It's usually descriptive and textual. Examples include someone's eye color or the type of car they drive. In surveys, it's often used to categorize yes or no answers. Quantitative data is numerical. It's used to define information that can be counted. Some examples of quantitative data include distance, speed, height, length and weight. It's easy to remember the difference between qualitative and quantitative data, as one refers to qualities and the other refers to quantities. A bookshelf, for example, may have 100 books on its shelves and be 100 centimeters tall. These are quantitative data points. The color of the bookshelf red is a qualitative data point. What is quantitative numerical data? Quantitative, or numerical, data can be broken down into two types, discrete and continuous. Discrete data. Discrete data is a whole number that can't be divided or broken into individual parts, fractions or decimals. Examples of discrete data include the number of pets someone has. One can have 2 dogs but not 2.5 dogs. The number of wins someone's favorite team gets is also a form of discrete data because a team can't have a half win, it's either a win, a loss, or a draw. Continuous data. Continuous data describes values that can be broken down into different parts, units, fractions and decimals. Continuous data points, such as height and weight, can be measured. Time can also be broken down by half a second or half an hour. Temperature is another example of continuous data. Discrete versus continuous. There's an easy way to remember the difference between the two types of quantitative data. Data is considered discrete if it can be counted and is continuous if it can be measured. Someone can count students, tickets purchased and books, while one measures height, distance and temperature. What is qualitative categorical data? Qualitative data describes the qualities of data points and is non-numerical. It's used to define the information and can also be further broken down into subcategories through the 4 scales of measurement. Properties and scales of measurement. Scales of measurement is how variables are defined and categorized. Psychologist Stanley Stevens developed the 4 common scales of measurement: nominal, ordinal, interval and ratio. Each scale of measurement has properties that determine how to properly analyze the data. The properties evaluated are identity, magnitude, equal intervals and a minimum value of 0. Properties of measurement. Identity. Identity refers to each value having a unique meaning. Magnitude. Magnitude means that the values have an ordered relationship to one another, so there is a specific order to the variables. Equal intervals. Equal intervals mean that data points along the scale are equal, so the difference between data points 1 and 2 will be the same as the difference between data points 5 and 6. A minimum value of 0. A minimum value of 0 means the scale has a true 0 point. Degrees, for example, can fall below 0 and still have meaning. But if you weigh nothing, you don't exist. The 4 scales of measurement. By understanding the scale of the measurement of their data, data scientists can determine the kind of statistical test to perform. 1. Nominal scale of measurement. The nominal scale of measurement defines the identity property of data. This scale has certain characteristics, but doesn't have any form of numerical meaning. The data can be placed into categories but can't be multiplied, divided, added or subtracted from one another. It's also not possible to measure the difference between data points. Examples of nominal data include eye color and country of birth. Nominal data can be broken down again into three categories. Nominal with order. Some nominal data can be subcategorized in order, such as cold, warm, hot and very hot. Nominal without order. Nominal data can also be subcategorized as nominal without order, such as male and female. Dichotomous. Dichotomous data is defined by having only two categories or levels, such as yes and no. 2. Ordinal scale of measurement. The ordinal scale defines data that is placed in a specific order. While each value is ranked, there's no information that specifies what differentiates the categories from each other. These values can't be added to or subtracted from. An example of this kind of data would include satisfaction data points in a survey, where 1 equals happy, 2 equals neutral, and 3 equals unhappy. Where someone finished in a race also describes ordinal data. While first place, second place or third place shows what order the runners finished in, it doesn't specify how far the first place finisher was in front of the second place finisher. 3. Interval scale of measurement. The interval scale contains properties of nominal and ordered data, but the difference between data points can be quantified. This type of data shows both the order of the variables and the exact differences between the variables. They can be added to or subtracted from each other, but not multiplied or divided. For example, 40 degrees is not 20 degrees multiplied by 2. This scale is also characterized by the fact that the number 0 is an existing variable. In the ordinal scale, 0 means that the data does not exist. In the interval scale, 0 has meaning. For example, if you measure degrees, 0 has a temperature. Data points on the interval scale have the same difference between them. The difference on the scale between 10 and 20 degrees is the same between 20 and 30 degrees. This scale is used to quantify the difference between variables, whereas the other two scales are used to describe qualitative values only. Other examples of interval scales include the year a car was made or the months of the year. 4. Ratio scale of measurement. Ratio scales of measurement include properties from all four scales of measurement. The data is nominal and defined by an identity, can be classified in order, contains intervals and can be broken down into exact value. Weight, height and distance are all examples of ratio variables. Data in the ratio scale can be added, subtracted, divided and multiplied. Ratio scales also differ from interval scales in that the scale has a true zero. The number 0 means that the data has no value point. An example of this is height or weight, as someone cannot be 0 centimeters tall or weigh 0 kilos or be negative centimeters or negative kilos. Examples of the use of this scale are calculating shares or sales. Of all types of data on the scales of measurement, data scientists can do the most with ratio data points. To summarize, nominal scales are used to label or describe values. Ordinal scales are used to provide information about the specific order of the data points, mostly seen in the use of satisfaction surveys. The interval scale is used to understand the order and differences between them. The ratio scales gives more information about identity, order and difference plus a breakdown of the numerical detail within each data point. Using quantitative and qualitative data in statistics. Once data scientists have a conclusive data set from their sample, they can start to use the information to draw descriptions and conclusions. To do this, they can use both descriptive and inferential statistics. Descriptive statistics. Descriptive statistics help demonstrate, represent, analyze and summarize the findings contained in a sample. They present data in an easy-to-understand and presentable form, such as a table or graph. Without description, the data would be in its raw form with no explanation. Frequency counts. One way data scientists can describe statistics is using frequency counts, or frequency statistics, which describe the number of times a variable exists in a data set. For example, The number of people with blue eyes or the number of people with a driver's license in the sample can be counted by frequency. Other examples include qualifications of education, such as high school diploma, a university degree or doctorate, and categories of marital status, such as single, married or divorced. Frequency data is a form of discrete data, as parts of the values can't be broken down. To calculate continuous data points, such as age, data scientists can use central tendency statistics instead. To do this, they find the mean or average of the data point. Using the age example, this can tell them the average age of participants in the sample. While data scientists can draw summaries from the use of descriptive statistics and present them in an understandable form, they can't necessarily draw conclusions. That's where inferential statistics come in. Inferential statistics. Inferential statistics are used to develop a hypothesis from the data set. It would be impossible to get data from an entire population, so data scientists can use inferential statistics to extrapolate their results. Using these statistics, they can make generalizations and predictions about a wider sample group, even if they haven't surveyed them all. An example of using inferential statistics is in an election. Even before the entire country has voted, data scientists can use these kinds of statistics to make assumptions regarding who might win based on a smaller sample size. Using data visualization to communicate insights. Data visualization describes the techniques used to create a graphic representation of a data sample by encoding it with visual pieces of information. It helps to communicate the data to viewer in a clear and efficient way. Characteristics of effective graphical displays. Effective visualization can help individuals analyze complex data values and draw conclusions. The goal of this process is to communicate findings as clearly as possible. A graphic display that features effective messaging will show the data clearly and allow the viewer to gain insights and trends from the data set and reveal the different findings between the data. Data visualization examples. The best visual representation of a data set is determined by the relationship data scientists want to convey between data points. Do they want to present the distribution with outliers? Do they want to compare multiple variables or analyze a single variable over time? Are they presenting trends in your data set? Here are some of the key examples of data visualization. A bar chart is used to compare two or more values in a category and how multiple pieces of data relate to each other. A line chart is used to visually represent trends, patterns and fluctuations in the data set. Line charts are commonly used to forecast information. A scatter plot is used to show the relationship between data points in a compact visual form. A pie chart is used to compare the parts of a whole. A funnel chart is used to represent how data moves through different steps or stages in a process. A histogram is used to represent data over a certain time period or interval. Quantitative messages. Quantitative messages describe the relationships of the data. Depending on the sample, there are different ways to communicate quantitative data. Nominal comparison. Subcategories are individually compared in no particular order. Time series. An individual variable is tracked over a period of time, usually represented in a line chart. Ranking. Subcategories are ranked in order, usually represented in a bar chart. Part to whole. Subcategories are represented as a ratio in comparison with the whole, usually represented in a bar or pie chart. Deviation. Subcategories are compared with a reference point, usually represented in a bar chart. Frequency distribution. Subcategories are counted in intervals, usually represented in a histogram. Correlation. Two sets of measures are compared to identify if they move in the same or opposite directions, usually represented in a scatter plot. Expand your data science expertise. With data science becoming a skill in even greater demand, now is a perfect time to expand your knowledge of the world's most valuable resource, data. A degree in data science will enable you to identify, analyze and present complex and interwoven webs of data. You can then leverage these insights to make predictions and create strategies, specifically in a business environment. The UNSW Master of Data Science can give you the skills you need to unlock the power of data and help businesses make better decisions, empowering them to drive significant changes and results.